How are our oceans? How much can they take? How does our world affect their world? What does it take to find out? For 40 years, Josep Pasqual has been on his way, again and again, since he was 13 years old, always on his way to the sea, which still catches his eye every single day. He has never tired of exploring new things about it, always on his way to the harbour, where his unusual excursions have always begun.
Ever since I was a child, I loved meteorology, and I loved the sea. And when I was about 13 years old, I became quite serious about taking notes. The first notes I threw away, but since I was 15, I kept all of them. My first observations were measured with tools that were neither very reliable nor very precise.
Josep Pasqual's curiosity about the waters of his coast is still as keen as ever. But his questions have taken on a very different meaning over the years. The temperature of the sea in his region has been the focus of Josep Pasqual's interest for a long time. The moment his father allowed him to take the boat, he went out. Even back then, he measured the temperature on the surface and in deeper waters, which is where he still measures the temperature today. Of course, his thoughts are tied to questions about climate change and the release of CO2 into the air. Of course, he is concerned about the warming of the oceans. So, of course, Josep Pasqual does not let the temperature of the waters on his coast, the coast of the Mediterranean Sea, out of his sight.
Now I've already accumulated data on the temperature of the sea, from the surface down to a depth of 80 meters, since 1973, so for about 38 years. My observations are weekly averages, and you can see that the temperature of the ocean, in line with what is already happening in the air, is warming up. Of course, closer to the surface, and not so much in deeper areas of the sea.
Close to the surface of the same waters where Josep Pasqual has observed the temperature of the ocean increasing over the years, a group of scientists has been taking a close look at the condition of marine life. Well-defined grids are always the starting point for their observations. With repeated observations of the growth cycle of some of the organisms inside the grids, the scientists made an important discovery. Some organisms had increased in size, although rising temperature of the waters had been observed, while others had slowed down or stopped growing altogether. So marine life seems to be affected by water temperature in different ways. It will always only be snapshots scientists can take of the ecosystem's condition. But over time, these snapshots will help them to discover which organisms in warming waters are endangered. Of course, scientists are not only monitoring marine life fixed to one place, such as underwater cliffs. Species that move around are also of interest to them. With increasing water temperature, exotic species may move in, while others may migrate away. Some organisms might be able to adapt to the changing conditions, while others might disappear, changing forever the biodiversity of our oceans as we know it.
This increase in the temperature of the sea, which is being observed these days, it really worries me. Not so much for the present, but definitely for the future.
Josep Pasqual is not only concerned about the increase in water temperature in his region. The pH level of these waters is just as much on his mind. So every week he collects water samples to support scientific investigations on ocean acidification. In Barcelona, water samples are in great demand to explore questions about ocean acidification.
For us, it's important if there's people, amateur scientists, that they can also even take samples for us. Like there is this man in Estartit called Josep Pasqual, and it's even more important that society and the public in general gets interested in this problematic of the ocean acidification.
The scientists need lots of water samples, like those collected by Josep Pasqual, to be able to monitor the pH level in a certain ocean region. And they need different water samples, from different places in the water, different seasons, different years, before they can say reliably that the level of acidity in the waters they're observing is rising steadily, and before they can determine by how much and how quickly this is happening. Because ultimately, the scientists want to make predictions about the problem of ocean acidification.
The levels of acidification that we've reached today, they don't have precedents over maybe 20 million years, and the levels that we will reach by the end of this century might have no precedents of over at least 40, 50 million years.
Our hunger for burning fossil fuels is causing an alarming increase of carbon dioxide in the atmosphere. Not only our climate, also our oceans are affected. More and more CO2 molecules are entering our seas. As the CO2 molecules react with the seawater, hydrogen ions are released. And the more hydrogen ions in our oceans, the more acidic the water. High water acidity, in turn, will affect carbonate ions. But carbonate ions are needed by many marine organisms as vital building blocks to form calcium-based skeletons and shells. The more acidic the ocean becomes, the more carbonate ions will be tied up by hydrogen ions, until carbonate ion concentration in the water becomes too low for calcifying organisms to remain healthy. Scientists around the world are shedding light on how ocean acidification can influence the health of marine life. And corals are in the focus of many investigations. In laboratory experiments, CO2 was released directly into the aquarium to make the water as acidic as it is expected to be in our oceans by the end of this century. With time, some corals slowed down their growth, while others even stopped developing calcium skeletons.
Our results of our experiments on ocean acidification in the laboratory, at the moment, the ones we've run with corals, they all indicate that corals will calcify less in the future due to acidification. And we've checked that with different species, and they all point towards this direction.
Already by the end of this century, the concentration of carbonate ions in some ocean regions of the world might be too low to support the formation of calcium carbonate skeletons and shells. The levels of acidity in these waters could become so high that carbonate skeletons and shells of calcifying organisms would start to break up and dissolve. This destruction of coral reef ecosystems could have devastating effects on other marine life, because many organisms depend on coral reefs for food. Without coral reefs, much familiar marine life would vanish. Predictions about potential effects of ocean acidification on marine life are not only based on laboratory experiments. Scientists are also studying such events up close in nature. Off the island of Ischia in Italy, underwater volcanic vents release large amounts of CO2. Here, it is natural acidification that helps scientists to take a look into the future. Far away from the volcanic vents, at a safe distance, researchers discovered the waters to be full of life. This far from the vents, they also observed calcifying organisms growing on seagrass. But as they gradually drew closer to the volcanic vents, these calcifying organisms on seagrass disappeared. And even closer, the acidity of the water became so high that corals, mussels and other living organisms could no longer cope. Natural volcanic vents therefore help us to see what some areas of our oceans may look like by the end of this century. Ocean acidification has already begun to challenge our seas on a global scale. With increasing carbon dioxide in the atmosphere, marine waters are turning more acidic. At the poles, because CO2 dissolves well in cold waters, but also in tropical regions, where coral reefs are located. Even if we stopped pumping CO2 into the atmosphere, acidification of the seas would pose a serious threat to marine life. Oceans are finite in what they can give and in what they can take. Their capacity to protect their inhabitants from human excess is limited. Oceans are where life began. They pose challenges, but they also provide the freedom to move in all directions.
I remember my father and my grandfather saying, "Shall we go fishing? Here or there? How will the wind be blowing tomorrow, like this or like that? Will the sea be smooth, or will there be waves?"